Okay, so a two-particle system with friction this time, but our friction is just labelled on. Okay, so we're just told what the friction is. So we don't actually need to worry about coefficient of friction, we're just told what it is. So let's label up the forces we've got. Okay, so the first equation I'm going to write is a kind of very standard question with the acceleration and the tension. So we're going to write 5g minus t equals 5a. And for this particle up here, we're going to write t minus 10 equals 3a. Okay, if we add them together, we get 5g minus 10 equals 8a. So a is going to equal 5g minus 10 divided by 8. And this gives me an a value of 4.875. So we'll round that to 4.9. Okay, to find the tension, let's use the second equation. So t minus 10 equals 3a becomes t equals 3a plus 10. And the tension, it should make sense that we add 10, because in the previous questions where there was no friction, it was just this 3a here. But because we've got this, which is our friction, we are adding to the tension. So more friction, more tension. Okay, so plug in the numbers. We get a t value of 24.6 newtons. Okay, so very similar to the non-friction situation, except for this bit here, where I put in the frictional force. Okay, so a 200 kilogram particle is hanging below this pulley, and it's pulling along this 120 kilogram particle. Coefficient of friction is 4/5, so quite high friction, very high friction actually. So we need to find the frictional force and the acceleration and the tension. Okay, let's label up to start with. 200g down, tension this way, tension this way. 120g down here. Reaction normal is here, and I haven't left a lot of space for this. FR is going to go here. So the first thing is to find the frictional force. So remember that F equals mu, the coefficient of friction, times the normal reaction force. So F equals 4/5 of the normal reaction force of this particle, which is 120g. 120 times 4/5 is 96. So our frictional force is 96g, or 940.8 newtons. Okay, question B and C. We're going to use our simultaneous equations. So we'll start with 200g minus t equals 200a. T minus our friction, which is 96g. The reason I'm using 96g is because this up here is in 200g. So to compare these two is going to be a little bit easier. And that equals 120a. Okay, that method again, we combine them. Okay, 200g minus 96g is 104g equals 320a. If I divide 104g by 320, I get an answer of 3.185. Okay, you can round that if you want. To find the tension, I'm going to use this second equation. So I'm going to write T equals 120A plus 96G. again, like in the last question, this 96G is the frictional force. Okay, so that's making this tension more, it increases the tension. So when I do 120 times by my 3.185 plus my 96G, and I work it through, I get 1,323 newtons. Okay, so in this question, it's really important that we read it really, really carefully. We know that we have a coefficient of friction of 0.5. And we know that particle A has double the mass of particle B. So let's call the mass A 2x and call mass B x. So if I think about the forces labelling on, this one's going to be x times g with a reaction normal this way and a friction this way. This particle is going to have 2xg as the force down and t as the force up. Okay, so the first thing to do is to work out the frictional force. So the frictional force, mu r, is going to be a half of the reaction force, which is xg. Now we can write our simultaneous equations. So I'll do A and B together again. So we have 2xg minus t equals 2xa, and for particle B I have t minus half xg, and that equals xa. Now I've combined these together, I get 2xg minus a half xg, which gives me 3/2 xg, and that equals 3xa. The nice thing here is I can cancel out my x's, and I'm left with 3/2 divided by 3. So 3/2 divided by 3 is a half. So I have A as a half g. Oops, -1, -2. Okay, so to work out the tension, I take the second equation again, and I'm going to write T equals XA plus a half XG. Now, what I know is that this A is a half G, and I have a half G here, so I have a half G X plus a half GX, which gives me T equals GX. Okay, so what this means is, depending on what the X is, depending on what the mass is, I'm going to times, in this case, in this scenario, I'm going to times the mass by G, and that gives you my tension straight away. So depending on what X is, the tension in the cable is dictated by that X value. Okay, so when we release this system from rest, it accelerates at 4.9 meters per second to the -2. The tension goes this way and this way. We have a force down of 8G, force down of 5G, normal reaction force this way, and we have a friction force this way. Okay, so use this as a starting point. We'll write our normal equations in order to help us. So we have 8G minus T equals 8A, and we have T minus FR equals 5A. If I combine these together, it's not going to help me an awful lot at the moment. Okay, the first thing to do is to find this FR and to find this value of T. So I'm just going to find FR really quickly. So FR we're going to write as mu times by 5g. Okay, we'll use that in our calculations. Let's take this first equation and rearrange it. We end up with T equals 8g minus 8a. So 8 times 9.8, subtract 8 times 4.9, that's our acceleration. We get 39.2 newtons. Okay. We can then use our second equation, this one, and rearrange it. So if I rearrange it for FR, so I'm going to start with T minus FR equals 5A, and we can fill in the blanks as we go. So we know what the tension is. The tension is 39.2. FR is mu times by 5g, and that equals 5 times A, which is 5 times 4.9. So if I rearrange this a little bit, I'm going to add this part over, so I'm going to end up with mu times 5g equals 39.2, subtract 5 times by 4.9. If I then divide this all by 5g, I get mu equals 39.2, subtract 5 times 4.9, all over 5g. Now, you might work in a different way. The way I work on this type of question, when they get a little bit chunkier, is that I don't do anything on my calculation until the last stage. And the reason I don't do that is because I don't like to end up with sort of decimals all over the place. Also, by doing it this way, you can almost check you're working through them and see that it makes sense. So once I do this, at this stage, I'll put it into a calculator, and that gives me an answer of 0.3. As I said, you don't have to work like that, you can do it step by step, but by doing this, you can see that all your working's there. I just think there's almost an over-reliance on your calculator straight away sometimes in mechanics, and you don't need to. You can work it through algebraically, and it's a lot sort of cleaner, and it shows your method much better. Okay, so we're going to put all these sort of skills we learned in this sort of little unit together. We have friction, we have connected particles, and we've got a lift system. Now, this isn't half as bad as it first appears, this question. We can label up what we've got, and it makes our life a lot easier straight away. T, 300G, Rn, Fr, combined mass is 280 kilograms. This should be becoming sort of second nature to you now, this labelling. Okay, so first equation, 280G minus T, 280A. Second equation, T minus Fr equals 300A. Okay, let's work out Fr. Let's do that over here. Fr equals 0.75 multiplied by 300G. This gives us 225G. Okay, combine these two together. I can change this Fr now. We can change it to 225. Combine them together, we have 55G equals 580A. So 55g divided by 580 gives us our acceleration, which is 0.93. Okay. Do we need to find the tension? No, so don't worry about it. You can if you want, but we've got the acceleration, which is the most important part. We now want to find this reaction force here in the lift. So let's consider our man. 80g down. We're travelling downwards at 0.93. Okay, so I do 80g, subtract Rn, and that equals 80A. Rearranging this, I get Rn equals 80g, subtract 80A. This means the person's going to feel lighter, which makes sense because we're accelerating downwards. So it's 80g, subtract 80 times by 0.93. We get a value of 709.7. This makes sense if we check it, because 80 times 9.8, which would be the kind of stationary weight, is 784. So that's lighter, so that makes sense. Okay, so put it all together. You can have a go at some questions out of the textbook as well if you want to follow on from this.